Okay, welcome back. So lecture 10, we're going to talk a little bit about a conjecture I posed last class and had you write out some example proofs of this conjecture. And then I'm going to probably pull up my computer and we'll do some like Python examples of stuff. Okay, so the conjecture that I asked you to write about is the following. So conjecture. So if X is rational and Y is irrational, then the product X times Y is irrational. Okay, so this was a conjecture that I posed. It was similar to one of the problems that we looked at. And it looks like only one person was able to get the correct answer. I need to finish writing out irrational. And it's okay. I gave you this as a conjecture on purpose to illustrate a point. This is false. Okay. And it's false because there is an example where it's false, right? So all of the statements that we've been looking at are almost like there's these universal quantifiers on the domain, right? So this would be like for all X, for all Y, X is rational and Y is not rational, implies that X times Y is not rational, right? So this is like using these logical quantifiers. So for this to be true, this has to hold for every single pair of X and Y. And it happens to be that it fails for one possible X, right? In the example, so you have to give a counterexample. So, and I've said this word before, counterexample. You just have to show that that fails for one pair of X and Y, and then the whole statement's false. So counterexample, take X to be equal to 0 and Y equal to square root of 2 or something. X equals 0 is a rational number, right? You can write it as 0 over 1. It's a ratio of integers with non-zero denominator. So that will be true. Square root of 2, we've shown before that that's irrational. So that would be true. So the hypothesis is satisfied. Then we check this. 0 times root 2 is 0, which means that this would be false. And we'd have true implies false. That's when the conditional statement is false. So that conjecture is false. And it's an important thing to remember that when I write conjecture, it doesn't mean that it's true, right? So that being said, looking at your proofs, I like them. And if we modify this statement, we can get something that's true. And then your proofs will possibly follow, right? So what we can say is maybe we can prove that, so this would be like a proposition. So I'm telling you this one is true. Okay, so actually, so the fix for this is to say if like x is a non-zero rational and y is irrational, then the product is irrational. Okay. So I'm looking at your proofs and they look nice, right? Like I really am surprised that you wrote them nicely. Right? Even though they're false proofs, they're in this correct structure. So I'm going to prove this for you. And my proof is going to look very similar to your proofs of this claim here. And we're going to find out where your arguments went wrong. Okay. So I'm just going to go ahead and for the, no, I'll do the scratch work first. So scratch work. So I'm assuming all of you, based off of what I briefly looked at, you were using proof by contradiction. So that means you're going to assume the hypothesis and the negation of the conclusion. Okay, so that means you'll assume that x is rational, y is not rational, and x times y is rational. So that's what all of you assumed, right? I'm not writing the non-zero part to illustrate the point. Like, where did you guys mess up in the argumentation? So then, with that information, we can say x is equal to a over b, and x times y is equal to c over d, where b is not equal to 0, and d is not equal to 0. And they're integers, right? So I'm assuming y'all said something like that. So then the contradiction that you'd like to arrive at is that y is both rational and irrational. So using this information here, we can say that x, y is equal to well, what can we say here? So we know that y is equal to c over d times a. Oh, no, sorry. What am I doing? C over d times 1 over x. Right? Just divide both sides by x, and that's what you get. Right? Which will be equal to c over d times a over b. Okay. So this is like, okay, this is equal to CA over DB. Where is there a problem? Yeah. Oh, yeah. 1 over x is equal to b over a, sorry. Right. Nowhere in this argument here are we guaranteed that a wouldn't be 0. And remember, the definition of being rational is a ratio of integers with non-zero denominator. Like if that a was a 0, then that product would be 0, and that'd be a 0 denominator. And so remember how I was saying that like it's important to make sure that those denominators are not 0. And this was a case where it could happen. So if we assume that additionally that x is not equal to 0, then that means that A is not equal to 0. You see that? The only way that X could be 0 is if A is 0. So then we'd have this, like this would imply that A is not equal to 0, and then we'd be good down there because D is already not 0 by definition. Okay. So let's go ahead and write the proof. Formal proof. Oh. Okay. So by way of contradiction, suppose so X, how am I going to write this the best way? Maybe X is irrational with X not equal to 0. Y is not rational, and the negation of the conclusion, which is that X, Y is indeed rational. Okay, so now we just apply the definition. By definition. So X is rational, so X is equal to A over B. And XY is equal to C over D, where A, B, C, and D are integers, and B is not equal to 0, and D is not equal to 0. I don't like how many times I said and, I'll say with. Okay. So then we can say that Y is equal to C over D times 1 over X. So then solving for Y, I'll say, so the reader knows. Y is equal to CD times 1 over X. And that's equal to C over D times B over A, which is just CB over DA. Okay, so then we have to make note that X is not equal to 0, which means that A must not be equal to 0, right? So since X is not equal to 0, A must not equal to 0, comma, so D times A is not equal to 0. Okay, and then I would say maybe like I'm running out of like room. I'll go ahead and write it here. Actually, I'm gonna, because like I erased that now, I'm gonna write it how I would have wanted to write it. So I'm gonna erase like a little bit right here. What I was doing was fine, but it's not like the best way that I felt it could be written. So, all right. So I just applied the definitions, right? Now, because I did that, the reader is immediately aware of what X is, right? It's A over B. So it makes more sense to me to now say something about A immediately after that sentence. So, we can say here, since X is not equal to 0, right there. It follows that I'll say like A over B is not equal to 0. Implying A is not equal to 0. So again, the reader should know that X is associated with is the same thing as A over B. So if X is not equal to 0, then A over B is not equal to 0, which means that A can't be 0. So it's more clear that way to me. Okay. Okay, so then we observe that, where is it? X times Y is equal to C over D, which is equivalent to saying that Y is equal to C over D times 1 over X, which is equivalent to saying that Y is equal to C over D times B over A, which is equivalent to saying Y is equal to CV over DA. Okay. Okay, so since D is not equal to 0 and A is not equal to 0, D times A is not equal to 0. And then I'll get fancy. I need a way to transition. Like moreover, CB and DA are integers. Hence, Y is rational by definition, a contradiction. So moreover, write that out. CD and DA are integers. With again, maybe I'll just like remind the reader with DA not equal to 0, which implies Y is rational. A contradiction. Or maybe just says which implies Y is rational, period. This is a contradiction since Y is supposed to not be rational. And then that would be, that's it. It's a contradiction, it's false, which means the original statement is true, because we just assumed the negation of the original statement and it's going to lead to a contradiction. Okay. So, important lesson, division by 0 always messes things up. In fact, you might see like this thing that goes around that like you can prove that 1 is equal to 2. you'll see this proof that that 1 is equal to 2, but it's false because there's a division by 0 that happens. You can't divide by 0. Okay. So any questions about the proof? It looks like you all were writing the right way, though. So I'm pretty psyched on that. All right. I suppose now I'm going to pause the recording and then get my computer set up to do a little bit of Python stuff.